everybody. My name is Ariel Furst, and I am faculty in the Chemical Engineering Department at MIT. And today I'm excited to tell you how we are going to revolutionize agriculture. Currently, chemical fertilizers support food growth for about half of the global population. However, they're also responsible for over 1% of greenhouse gas emissions. They destroy native ecosystems, and about 20% of fertilizers are wasted as runoff. And this is a huge challenge right now because fertilizer prices have more than doubled in the last year. In nature, microbes make fertilizer. They cycle nutrients and fix metals. So why haven't we been able to commercialize this? Well, that's because these microbes are very sensitive and they need to be alive when we deliver them. So currently we know how to grow microbes, but we can't process, store, or transport them effectively. That is until now. I'm here to introduce a self-assembling coating called Pharmor that forms on individual microbes and protects them from manufacturing stresses, enabling us to produce, distribute, and transport these microbial fertilizers. Our coating forms in seconds on microbes. We normally have a video there. It coats microbes in seconds. It's readily integrated into existing manufacturing lines, and the components of this coating are inexpensive and safe. Additionally, we can tune these coatings to protect against additional stressors. And one of the key stressors that's important for agriculture is freeze drying. When we deliver these microbial products, they have to be freeze dried for transport and effective delivery. So we can see here, we have coated microbes on the right, and the green microbes are alive. And we can see way more green microbes on the right than on the left. Additionally, our coatings are uniquely effective at protecting against heat. We can see here for uncoated microbes, they die if they're not refrigerated. In contrast, our microbes, our coated microbes, not only survive, but thrive at temperatures even above room temperature, removing the need for a cold chain. And this is why we are the only effective technology to protect microbial fertilizers. When we look at other technologies like microencapsulation, they protect, but they aren't scalable. We have protective additives like cryoprotectants that are not universally effective. In contrast, our coatings are scalable. They're universal. They protect every microbe we've tried, anaerobes, aerobes, gram-negative, and gram-positive. They enable us to store those coated microbes at ambient temperatures, and we can protect them from additional stressors, including reactive oxygen species and UV light. And we can do all this at a cost that's 2 orders of magnitude less than current technologies. Our anticipated incremental cost per acre is 0.03%. It's a negligible amount. And so what this means is for the first time, we can actually make these microbial fertilizers. We can improve their viability by 3 orders of magnitude, We can enable their ambient temperature storage for 10 times as long as they currently are stored, even under cold chain. And when we apply this to the agricultural fields, we can increase crop yields, while also supporting a sustainable agricultural ecosystem to prolong the lifetime of our crops and our farmlands. And so currently, we're targeting partnerships with microbial agricultural companies who cannot manufacture their products. Microbial agriculture is a $4.3 billion market with a 12% CAGR, but we anticipate with our technology taking a large portion of the overall fertilizer market, which is $180 billion. We have both a proprietary screen and the capacity to manufacture coated and freeze-dried microbes. We have 4 initial agreements with companies such as these, and we anticipate $2.3 million in revenue our first year, assuming only 0.1% of the United States market. And so where we are now is we've raised some non-dilutive funds, and we're doing the Delta V Accelerator this summer. We plan to incorporate in early 2023, followed by a Series A round in 2024. And our team has the unique combination of expertise needed to make this successful. We have a CEO with over 10 years of experience in product development and launches. We have 3 technical experts from my lab, Thomas, Stepp, and Broth, who have expertise in both these coatings and process manufacturing and scaling. And we have advisors with more than a century of combined experience and $7 billion in funds raised previously. And so taken together, this will enable us to develop a sustainable agricultural system with enhanced crop production. And what that means for us is both high revenues and significant market share. And so I'd like to thank you for your attention, and I'm happy to take questions.
Awesome. Thank you so much for that. So 2 questions. Can you walk us through the manufacturing process, and then can you go into a little bit more detail about the revenue model?
Yep. I'm not going to click back through, but basically right now, microbes are grown in batch and then freeze-dried. Basically, our coating self-assembles, so after you grow them, you incorporate our coating. It's a one-wash step, and then you freeze-dry them. It's very simple. It takes minutes to incorporate, and it's highly scalable. Revenue model, that 2.3 million is an estimated 300,000 from that initial screen I mentioned, which is anticipated to be a one-time fee per species of microbe to optimize our coating process. We'll then charge a recurring fee based on batch manufacture for the providers.
Can you talk a little bit about those 4 contracts that you highlighted?
Mm-hmm. So we have been in discussions with companies for a long time who are incredibly frustrated with the fact that they have these microbes that work on the small scale and they can't make them large scale. So we have initial agreements to basically do that screening, the portion of it, and we are then going to scale with a field trial with Indigo Ag.
So then timeline to commercialization is for broader scale, like
January 2023 is when we would move to CMO manufacturing.
Could you talk a little bit more about your IP as well?
Yeah, so we currently have one very general patent that's being converted through MIT. We already have several others written that we're planning to file external to MIT that are more on these specific manufacturing methods, but currently we cover microbes generally, our coatings for processing and manufacture, and applications beyond ag, including living biotherapeutics and probiotics.
All right, thank you.